for the false start here, folks, but we're going to go ahead and get started. So today we're talking about Xamarin.Forms at scale. And this is just going to be a brief rant, right, about how to develop scalable enterprise solutions. So this is literally going to be a rant. This is me on my soapbox, complaining. Complaining is a rough word, right? But talking about the things that we as software engineers face at scale in enterprise applications. Want to point out that these thoughts are my thoughts. They are not necessarily shared by my employer or anybody else. But this is water cooler conversation about enterprise software that I've had throughout my career. Things that we talk about, things that we see as problems. And I'm going to relate these things specifically to Xamarin and MVVM, more specific MVVM, but all of this is directly applicable to Xamarin as I've been using these techniques in Xamarin applications for the past, 6 years, maybe. So I can adjust my screen resolution a bit. Yeah, I can. The font looks, yeah, okay. Hold on one second. Let me see if I can adjust my screen resolution. Not sure if I can do it without coming out of full screen mode. So let me try something real quick. Let me grab RDM. And let's try putting it here and see if this gets us some lift. Let's see how bad this looks. Is that better? Does that look better to folks? Okay, good. All right, so I'm Rodney. You can find me on the internets, all the various places. Come, let's talk. Let's talk about enterprise software. Let's talk about .NET. Let's talk about the future of .NET. Xamarin 5 just dropped, or I'm sorry, .NET 5 just dropped. Xamarin 5 is coming. .NET 6 is on the roadmap. Like there's a lot of churn going on to move to a singular .NET. Like let's talk about it. Let's figure out how we can make it better. So the scale, right? Every project is a balancing act, right? We have resources, we have time, we have scope, we have developers, we have complexity, and these are all things that we have to balance, right? So like when we're talking about scale today, I'm not talking about like scaling up or scaling out a server. I'm not talking about the scale at which the application has to run hundreds of thousands of users, even though that is important, right? But and the things that we talk about today are going to relate to that, but we're talking more upstream, right? How do we scale a team, an enterprise team? What are the practices, the patterns and practices that we need, right? Patterns are what we say we do, and the practices are what we actually do. We're going to talk a little bit about MVVM, and we're going to talk about how to build, how MVVM is the way to build production scale apps in .NET. MVU is an emerging pattern to pay attention to, but right now MVVM is the staple of .NET applications. And Microsoft has been using this to success for years. We're going to talk briefly, like very briefly, about automation, more so to tell you that you should be doing it than anything else. And then we're going to talk about testing, the redheaded stepchild that none of us developers really like to talk to about or with, right? We never like to really deal with testing because testing implies bugs, and bugs are things that we don't like as developers. So we're going to talk about honestly, we're going to talk about developer testing and upstream, or I guess it's upstream testing, right? So closer to the metal, right? Developer testing, integration testing, UI testing. We're going to talk about those things as it relates to automation. So I'll go ahead and give you this disclaimer right now. There is no silver bullet. There is no one thing that is going to get you this key to success. So I'm going to nerd out for a second. Like these are the voyages of the Starship Enterprise. But like the reason why I chose this is because like it points out a very good picture, right? What is an enterprise? An enterprise has a large crew, right? It has a singular mission, and it's a singular entity with many different parts, right? A lot of different pieces that go into what an enterprise is. Right. And then enterprise software ends up being like a conglomerate of those things. Right. We end up having to pull stuff from some legacy system that's still running COBOL because it's the only thing that does ordering properly and they've never rewritten it. Or you have the scenario where you've got to deal with some obscure security reason because the security people in the enterprise are extremely interesting in what they think is important. So, you run into these very interesting large scale issues in an enterprise, and it takes a scalable team in order to be able to deal with that, right? So the hard part about it is it's so much, right? It can be so much, and there's so much there. There's so much to unpack in an enterprise. The question that you ask is usually met with, well, that's just the way it's going to be. Or, that's because that's the way the enterprise does it, right? So you somewhat lose your sense of self on the enterprise, right? But this gets into scale, right? Because that enterprise solution has to scale for hundreds of thousands of users, depending upon what software you're releasing, what the actual software is. It needs to be able to handle hundreds of thousands of transactions. So, like, what really is scale inside the enterprise, right? Seems like. So things that you deal with in the enterprise is going to be stuff like team size, right? A large Xamarin team for me is 5 people. An indie developer in Xamarin can get the job done, right? Depending upon the size of the project. But if the size of the project, the scale of the project is so vast that you need more, you could have up to 20, 30 developers in a single mobile application. So team size becomes one of those things inside the enterprise that can become, a deterrent or can slow down velocity sometimes. Requirements shift, right? We're all developers. We know how that works. What's gold today is trash tomorrow. And even though you got a hard firm yes that this thing needs to happen today, tomorrow you could end up with, oh wait, yeah, we're not going in that direction anymore. We as developers don't sometimes get the requirements, and when the requirements are not clearly defined, or if they are changing from day to day, we may be working on outdated requirements or not understanding the change in the requirements, and we end up implementing the wrong thing, and that can lead to ambiguity and understanding. And then there's complexity, right? There's a lot of complexity when it comes to enterprise, right? There's modules and widgets and zots that have been there for years that one guy understands, and he's the only person that still understands it, right? And he's about to retire. So there's all of those things that you deal with in terms of complexity, right? Like decisions have to be documented because when complexity shifts, when those requirements shift, right? Technical debt has to be tracked because that's part of your complexity. All of those things are really the complexity that we deal with in the enterprise, but the enterprise doesn't really operate by itself, right? It's just a machine, right? If it doesn't have a crew. So again, I'm going to nerd out today a little bit. So we're going to enter the product delivery team, right? So, you've got your good old fashioned product owners. These are the nice folks that are super smart. They know the business through and through. They can tell you why this thing needs to be read because some guy left some comment, 10 years ago on some previous version of the app that said that red is best, right? They can give you all that information. They provide the requirements that you're coding to, the acceptance criteria that defines your definition of done, and they get answers when functionality is supposed to do a certain thing. Hey, product owner, I don't know, when is this thing supposed to turn on or off? Is it in response to the value being changed, or is it in response to the focus being left, right? Those are the things that the product owner can tell you, right? They can tell you how it's going to feel, how it's going to look, and they represent the business, right? They represent the people that we are trying to provide value to. They represent the people that are funding the endeavor, the project that we're on, right? So they're really the people that matter, right? They're the people that we're trying to satisfy. You got your developers, right? These guys move the ship, right? They literally move the ship, right? You got your architects, you got your developers, you got the guys at the helm, right? They're there to do work. They are there to get work done. They are there to think when needed and work as hard as they can to deliver value, right? They are the ones that have to answer to the product owners when things do not look the way the product owner expects, and that's that relationship there, right? But they convert business to technology, right? That's their job. They take something, or they take abstract concepts and acceptance criteria and make them into something, right? And that's a very important thing. And then we got our testers, right? So it's funny because the communications lieutenant is in the back, and really what it is and how I try and define testing is testing verifies the communication between the business and the development team, right? They are the ones that are making sure that we're speaking the same language. If the product owner said that the acceptance means this and the developer provided this, then the tester should expect everything to be in alignment. And when the tester finds things that are incongruent with those conversations, they raise issues or defects or bugs, right? So making sure that that language is correct from product inside the product delivery team, right? Like, so it no longer is it the development team or the test team or the project manager, right? We are one product delivery team steering this enterprise solution towards a goal. And those testers are important because they have to keep us all honest, right? They're the ones that are going to find that obscurity in the acceptance criteria, because they're the ones that are actually using it. Because the developer is going to go write some code, verify that it works, ship it, right? The tester is going to be the one actually, pull the refresh, and hey, on the third time I pull it, it doesn't work. Well, is that a miss? Is that a bug? Where does that work, right? Where do we find those gaps? So understanding that it's a team structure, that we all work together, moving this thing towards a common goal is important, because I can't tell you the number of conversations I personally have had. I'm a developer just like the rest of you guys. The conversations that I've had where, oh, well, the tester is not testing the right thing, or, oh, the developer didn't deliver the feature correctly. Like, those are toxic conversations that don't get us anywhere, right? That's circular conversation. That's he said, she said, that's pointing fingers and laying blame, right? Like, that's not productive. That, again, we're the product delivery team. We have to be productive towards delivering this product. So we have to be very careful as a product delivery team to make sure that we're focusing on these things, right? So like, we have team complexity, right? And communication is the key to any relationship, right? In the times of COVID where everybody's working remote, like, pick up the phone, get on Teams, get on Zoom, get on Slack, pardon me, get on whatever medium of communication is your medium, and have a conversation. I don't understand what you're asking me. I don't understand your comment on my pull request. I don't understand what this acceptance criteria means. Like, don't wait if you have questions. Like, waiting to ask questions is probably the worst thing, right? And the only bad question is the one that's unasked. Claire Novotny, the executive director for the .NET Foundation, when I first met her a couple of years ago, she told me, ask your question, Rodney. Ask the question because you don't know who else needs to hear it. If you have the question, somebody else probably has the question, and they might not be bold enough to ask. One thing that I state is I'm willing to fail fast, right? I'm willing to admit what I don't know. So when it comes to a teaching moment, please teach me. Show me something new. Show me something better. And not everybody's there for that. So asking the question, making that communication effort to help somebody bridge those gaps is very important. Practices, right? So now we're talking about like team practices, like the consistent habits that we build from the patterns that we adopt, right? Practice makes perfect. If we aren't practicing the things that we say that we're doing, right, we're not actually doing them. Like, so when we need an algorithm to split polymorphically, and we don't use the strategy pattern, we should probably, ask that, are we practicing, what we say we're going to do, right? And these are things that increase team complexity, right? Because not everybody has the same skill set, not everybody has the same knowledge. So how do we level that playing field, and get our engineers to apply the philosophies that we are adopting? And then delivery, right? We got to deliver code. Code is the product. I was having a conversation with a colleague of mine the other week, and he says that if we're doing merges and we're causing regressions, then we are basically wasting money because the client has already paid for that code, right? The code is the deliverable at this point, right? There's other deliverables like binaries later, but right now the delivery in this particular portion of the scale is the code that individual developers ship, right? So we want that to be in small, manageable commits, right? Easy to revert problems, right? Rodney commits some really junky piece of code that breaks up the entire production system. It should be very easy to just do git revert and revert that commit and push a hotfix, right? Or if you're doing the fail fast, roll forward, then you fix it and roll it forward, right? But whatever it is, it should be small enough for us to easily identify what the problem is. The larger the commit, the harder it is for us to identify potential issues, the harder it is for us to regress, and all of those other downstream things, right? When we deliver code, we should be using some type of some type of template for how we commit the code. We should be making sure that we tag it to whatever our work item system, whether that be Jira, Azure DevOps, or Confluence, whatever we're using for our issue tracking, right? Like we should use a common way to make sure that all of that's there so that we have tracking, right? That reduces team complexity, because then when Rodney's out on vacation, somebody can say, hey, Rodney pushed this commit for this feature that went in this week, and that's why it's broken. So, hey, let's go ahead and revert it, and he can fix it when he comes back. And then breaking up the work to ensure that there's manageable streams for the incoming pull requests. Having to anyone that has to review code knows that reviewing large chunks of code is always more aggravating than reviewing small chunks, right? Because case in point, I've done pull requests that have done touched hundreds of files in a library, and it's just like that requires somebody to go through one by one and review that. Now, there's merit to say that the review is not going to catch everything, but those are things that we have to worry about in terms of complexity when we were talking about delivering value. So digging more into team practices, right? Like we can create code documentation, right? We can create, and this is XML document for the subsystem, right? Like we're talking about code level documentation on your interface. Go ahead and hit the 3/, or if you use Roslyn, I think it's control dot, and it'll tell you to go ahead and add code docs. Ghost doc is another tool that I've used before. Like create documentations for the subsystem. They show up in your IDE. And that's, I think, the most important part about it is when you're looking at something from the subsystem, right? When you have a large team, when you have a big scale of people looking at things, I want to give a developer clear understanding. When you depend on this interface and you use this method, this is what this method does. And if all they have to do is hover over that method, when they're pulling in that interface to find that out, it makes it way easier for them to understand. And then if they have a misunderstanding, again, communication, they pick up the phone, call me. Hey, Rodney, I see this code doc says this. I wanted to do this. What can we do about that, right? So constantly kind of bringing those things back together and getting alignment on that is very important. Another thing is adding markdown documents directly to your code base, right? Document your team's recipes. So there's patterns, there's patterns, principles, practices, and then there's recipes, right? So like there's going to be these specific things that your application does on a consistent basis. So you can build recipes around how your team is going to interact with the frameworks that they choose, the libraries that they choose, right? And you can document that right there in your code. So that way, when you onboard new developers, if you're scaling up the project, because you got to get it done faster. Hey, we got to get 50 more developers in here next week, otherwise we're not going to make the deadline. Then you have a place to show them, hey, these are our patterns. This is what we practice. And it's right there with the code. So as soon as they get access to the code, they have access to the documentation. This is an interesting concept that I'm starting to play more with because it's been helpful for me to see how a team actually does implement these recipes against these different frameworks. And then pairing, right? So like pair programming is one of those things, like I guess it came in like extreme programming and everyone's like, oh, pair programming. I'm not going to sit here and say one guy's got to drive, one guy's got to steer, but like sometimes you need a rubber duck, right? Sometimes you need something to squeeze. Sometimes just taking that second to explain it to another developer will give you an insight. So now this is something that I missed when I was an individual developer, right? I did not have those pairing sessions. I did not have any of this team practices. It was kind of whatever my practices went. And while that's good and bad, there's a limited amount of growth because I'm not being challenged by any other brain to look at the problem differently. And that's one of the things that I love about pairing, right? We talk about this thing, this trademarked thing, and we're going to build this thing. And then we get caught into semantics. Is it a provider? Is it a service? Is it this? Is it that? It's a thing. It's a thing. And as we talk about the thing will tell us what it wants it to be, right? As we pair and we go through the public API services, we see where it's actually going to be consumed, and we see what this thing actually is going to be responsible for, then we can name it, right? But if we get caught up on naming too early, we tend to get caught in naming and never really get to the meat and potatoes of, hey, I am building an abstraction that will do something, right? That something is what is important. Right. So that pattern will start to show itself as we start to understand what this thing's responsibilities are. Right. So pairing has become a very interesting thing, even remotely in these times of COVID. It's been very, very useful to get on and have a rubber duck or get on and show somebody how I'm working through a problem and get their feedback. Hey, that violates this principle. You should change this. Hey, how are you intending to use that? That pairing session is important. And then subject matter experts, right? Give the resources that are good for the task, right? Let your best XAML developer, write XAML in the UI, right? It's okay to do that. Don't, force, we got to get stuff done. And find a way to break up the work that you are giving your experts in specific areas, because all developers have a different skill set, right? My skill set is not XAML. I did not start off as a XAML developer. I know people that do XAML way better than me, and I learn from them because they are the subject matter experts, right? I can sidle up next to them and get them to show me these things. So give the subject matter experts those things so that they can write the documentation, they can create the presentations, right? They can go do the pairings and teach the team what the team practices are around these things. But we need to align, right? That's the other thing, is like team alignment. So we need to have alignment on what we think and how we do things. So I won't use the lemmings concept, because we're not lemmings in the enterprise. We're really more of a crew, right? Everybody's got a job to play. My job is to make sure that the network calls are correct. Your job is to make sure that the UI is pristine. Somebody else's job is to make sure that the view models are whatever the case may be, or maybe we're full stack and maybe we go all the way down, right? But we solve problems. So we have to come to alignment on how we solve the problems, right? We have to solve them efficiently, and we should have a standard approach, right? A standard approach for solving the problem. And I think that's the main thing. And I know it gets cookie cutter, and I know like we lose our individuality, but we're not supposed to be able to tell what another developer's code looks like anyway, right? Like that's supposed to be one of the myths of software development. So inductive proofs, I hated them during high school, but it was a common, consistent approach to solving a problem. And even though I don't like it, anybody that's ever had to learn that approach can easily say, yes, I know what an inductive proof is. Does it mean that they know how to do it off the top of their head? No. Will a little Googling be involved? Probably. But if they've heard it, they can cue back to it, right? So we are solving problems in a consistent way as a team, right? We are identifying problems, right? Like we have to raise the flag. It shouldn't be that, oh, I found this thing while this is happening and I let it go and QA finds it, right? I have developers all the time. Hey, Rodney, you checked in code and broke something. Or I'll tell developers, hey, you checked in this code. I'm commenting this out so I can get my pull request through, or I can unblock QA, right? Because we're moving fast, right? The enterprise is moving at light speed, right? We've got to fail fast and move fast so that we can deliver value fast, right? And then we always take that moment to sit back and assess. So we don't want to wait to identify the problems. We want to bring it up immediately. Hey, Rodney, you broke it, fix it. Then we have to figure out, what are we identifying as a problem? Is it a technical problem? Is it something that technology can solve? Can we get a library to do that thing? Is it something that the business needs to solve? Is it that they need to go back and redefine the requirements because they have requirements that are doubling back on each other, that are contradicting each other, right? And then testing, is it a testing requirement? Like, is it a testing problem? Do we have to figure out how the testers are going to be able to test this new feature that we're putting in? And then we have to have alignment on how we break down the work, right? Because we want to create a cadence, right? Like, how do we tackle it? And obviously the answer is scientifically, right? Like we tackle these things scientifically, but like we break down the work in ways that make sense for the business, right? If it's a screen, implement the screen. If it's a domain object that's supposed to do something, it's a domain object, right? Like break up the work where it makes sense and identify ways that your team can break down that work. And always check back with the team when you're breaking down the work. Does this make sense, right? Are the teams, like if there's multiple teams, right? Because like, let's say you've got 20 developers, you might have multiple Scrum teams, right? So how do we figure that out, right? And then team process, right? Have a template for how you structure the work, right? A template for your pull requests, and reviews should honestly just be a formality, right? And when I say formality, the approach should be vetted, right? It shouldn't be that the reviewer is getting to the code review and they're seeing the code and then they have to figure out what approach you took. It should be, you've already talked to an architect, you've already figured out and come to an alignment on the approach. And when they get to the pull request, it should just be reviewing what they already know, right? Making sure that you already did what you said you were going to do. And I always talk about at a place I used to work, we had this thing called the Gauntlet, and that was the pull request review was called the Gauntlet. And I remember I got a pull request rejected one time, and they told me to go and rewrite it from scratch. Like the architect told me, just go rewrite it from scratch. And that wasted a lot of time, right? And wasting time is not something that we can do in an enterprise because we got to move fast. Everybody's got a job to do. And if I'm not pulling my weight, the entire enterprise suffers. Right. So then we also have to create a structure in cadence for that work. Right. So like when we're doing the template for the pull request, we're trying to, make sure that we have completed all the work. Right. And and creating small chunks helps us get smaller pull requests, but it can also create gaps. So you have to mine those gaps. So practice is really just the application of the pattern that we adopt as opposed to the theory of its use, right? A good practice is the act of implementing good patterns. Good patterns have been established and are still evolving, but use established patterns, right? That's the theory by which we go to solve the problems, and then implementing the patterns properly is how we get good application, right, out of those practices. So like, what are patterns, right? Patterns are reusable things, right? You can take this thing and duplicate it very easily. So patterns that we use in software development are things like solid, the gang of four patterns, grasp, dry. These are all patterns that we use, right? And they're things that allow us to have a consistent language as developers to approach these problems. And in an enterprise, that's important, right? Because if Rodney goes off and writes some really new whiz-bang module, but Rodney's the only person that understands how the architecture is laid out, that's going to cripple the business, right? That's why there are COBOL applications. Well, that's not why, the only reason why, but that's why there's COBOL applications out there still, running large-scale business processes, because some one person had all of the knowledge around how the implementation was done in their head, and they were creating job security. And while it's great to have job security, I find that understanding these patterns creates more job security, because now I can go replicate these things over and over again versus having to hold on to one little piece of stuff, right? So we'll just jump right in, and I'll start talking about solid, because solid is kind of where I'm going to talk about here, because it's .NET, and we're talking about .NET native applications. So single responsibility, single responsibility is a single thing, right? I do one thing and I do it well. Violations of single responsibility, like if your method is doing more than one thing, it violates single responsibility. If your class does more than just what it's named to do, it violates single responsibility, right? If you want to cram in that extra bit of code just in this little method because that's the only place it is being called, it violates single responsibility, because I guarantee you somebody else in the enterprise is going to want to use that chunk of code somewhere, and it's stuffed in some private method that they can't get access to. And now we've got an issue, and we've got to figure out how to scale this out even more, when we could have just ensured that we followed good patterns, right? So violating single responsibility adds technical debt, right? Keywords like and or show us that we're violating single responsibility. And if the violation is intentional, you can use these words, right? Add or update, get or create. Those are places where, yes, we know we're violating single responsibility, but we're doing it and we're letting anyone that's consuming us publicly know. Right. And this becomes important where you're dealing with, again, talking about enterprise and scale. If the web team gives you an interface or a contract to code to, right, to get data from, then you have to respect that contract. And if we're doing too much, not respecting that contract, or if they're doing too much behind the scenes, all of that will come to light, and we'll have side effect code. I always tell this joke about this dev that reran the method twice. This method had a single responsibility, which was great. And that single responsibility was enforced. That was great. And there was a bug, and calling the method twice fixed the problem. Obviously, the method wasn't doing what it was supposed to do. And that was a great point to figure out why, but the developer just checked in the code and ran it twice. And we start seeing all sorts of other defects. So there you go. Inversion of control. This one is an interesting one to me, because the majority of the time that I talk about inversion of control or have conversation around it, everyone says, oh yeah, I use an IOC container. And it's like, inversion of control actually has nothing to do with the container itself. Inversion of control is about not having a master control program, right? The Tron reference and the MCP. We don't want a master control program. And in inversion of control is actually talking about depending on interfaces. So it kind of overlaps somewhat with dependency inversion. But inversion of control forces us down the interface depending on interfaces so that we can easily mock the control flow, right? Now the concrete thing being passed in isn't dictating the control flow of the program. The interface is dictating it, and we can swap out that interface for a different strategy if we want, or a different facade if we want, or whatever, decoration we need to do, right? But depending on that interface is important. I hear a lot of people talk about service locator being an anti-pattern. I actually worked on a large scale SaaS system where service location was actually used in conjunction with a container. And the service locator was actually being injected. Great, the service locator is being injected. The service locator still doesn't allow testability, right? So when we talk about these anti-patterns in inverting control, like they're not just things that can cause problems, or they're not just words and rhetoric. They're things that can cause actual problems in your scalability of your software, right? Because it has testing implications, passing in that service locator. So inversion of control is really about letting the framework make the calls, right? Letting the thing behind the interface make the call, and then you can you can allow that to be controlled somewhere else, and you don't have to worry about the implementation details. And this has actually, I'm going to take a segue. This is related to event-based programming. I apologize for anybody listening who thought I was going to talk about reactive programming today. I'm going to talk about it very little, but this is where I am going to talk about it. Event-based programming is actually kind of an inversion of control thing, right? So events happen, right? So the framework tells you that something happened, and then you can respond to the framework doing something and invoke a handler or subscribe to the event, right? And then we can extend the subsystem by responding to the events. We can dictate how the framework or how the application responds to the framework based upon those events. So inversion of control is really about inverting the control flow of the application and not using a IOC container. Okay, so dependency inversion, right? And I'm not going to talk about all of Solid. I'm only talking about a couple of things, and it's funny because the two that I didn't talk about are probably going to be the most relevant to what an MVVM framework is, which is the next part of the talk. So here we go. But dependency inversion is this fun thing, right? Like, again, it's not an IOC container, right? It's about this principle really speaks to understanding how to properly inject and abstract the modules of your subsystem. Right. So again, we're application developers. We do MVVM. We inject stuff into our view model, and those things that we inject are actually part of our subsystem, whether we pay attention to it or not. That is our subsystem, right? That repository or that service or that dialogue service or whatever the case may be. Those are dependencies that are our subsystem that will help our application function correctly, right? So these abstractions that we build should not depend on details, right? The abstractions themselves should not depend on the details of other things. The abstractions should be built in a way that allows you to not depend on those details. So in our case, as Xamarin developers, the majority of the time, our concrete thing is our view model, and we want to inject the non-details into our application. So we don't want to inject a concretion into our view model, because that immediately means that we have to take the details of the abstraction. And abstraction in the .NET space is a weird thing, right? Because you have interfaces and you have abstract classes. And I'm going to talk about that for a quick second, because this actually impacts testability. I have had conversation ad nauseum and heard talks around, interfaces are, too many is bad. Yes, too many interfaces is bad. Not enough is bad too, right? Because this impacts the testability. If you inject a concrete object into the view model, that immediately means that the view model is not testable. If the view model is not testable, you can't test your MVVM states. You get no lift. You get no additional, downstream communication with testers, right? Like, you aren't covering your cases, and this can really have a bad impact on testing. So, if your subsystem doesn't adhere to the dependency inversion principle, at minimum, your view model should, and we'll get to that a little bit later when we talk about view models. But again, talking about abstractions, too many abstractions can be bad, right? Don't abstract all the things. Pay attention to where those seams are. Understand that the system, like what the system depends on versus what the abstraction is, right? Like Notatime is this awesome library that does time, complexity, and it's great, right? But Notatime is the abstraction, right? You shouldn't have to go write a full-on abstraction later on top of Notatime, right? You just accept that Notatime is an abstraction that your system depends on, and hope that it's built in a way that allows you extensibility. So looking at this, right, this gets back to the whole dependency inversion principle. Yeah, we have this concrete dependency. We have this thing service, getting back to our trademarked thing earlier, right? We're not going to get caught up in what the thing is, because we're enterprise developers. We gotta move fast. We'll worry about what it is once we determine what its behavior is, right? So this thing service has a concrete dependency, right? And that violates the dependency inversion principle, right? It actually technically it violates the inversion of control principle, but whatever the case may be, right? These are things that we don't want to do. And this is what we mean by injecting concrete dependencies, right? So, okay, now let's look at this, right? We have our abstract dependency, which gives us, some method. And then we've got our concrete dependency, which implements our abstract dependency, which is just an interface. And interfaces in .NET is a very powerful, awesome tool. One of the things that they allow you to do is create a very thin veneer. So you'll notice here that now I'm injecting my abstraction, my interface, right? So that means that this thing can, as long as it adheres to the interface, it's good. And we don't have in .NET we don't have multiple inheritance. So injecting an abstract class is sometimes not as good because you still have to take whatever dependencies that the abstract class takes. Getting into interface segregation principle, we're going to gloss over this real quickly, but we're talking about it because it's important, right? We're talking about the subsystem. Make the subsystem small chunks, right? Just like we talked about, the work should be in small chunks, the interfaces should be in small chunks. That way it makes it simple for me to implement an interface in that small chunk. So this is an example, right? I have configuration, and this is very simple. Like it declares exactly what it is, what it does, and it's a very small piece, right? But it's a smaller piece of a bigger puzzle. This code is using C#8 default interfaces, and it's creating composable interfaces from other sets of interfaces, right? It creates an is-a relationship from the composition, but each one has a single responsibility, right? Each interface has a single purpose. So this is kind of showing ISP and SRP, so interface segregation principle and single responsibility principle at the same time, and it allows you to consume only what you need, which is kind of the key here, right? Like I don't want downstream consumers to have to take more. So composition is the classic composition versus inheritance, but like composition is the has a relationship. I have a dialogue service, I have a navigation service, and these things should be autonomous pieces that are brought into your system. Inheritance is like that is a relationship. I am a thing, like I am a wolf in sheep's clothing type thing. And it's important I bring up interface segregation principle here because, again, C# doesn't have multiple inheritance. So we want to make sure that I am a thing is important, right? Like I can be an interface, but the second you make me a concretion, I have to take all of the dependencies of that concretion. So using inheritance and interface segregation principle can get you a lot of lift in your subsystem and make your entire subsystem more mockable and more testable. Oh goodness, I'm running up on time, and of course, all that technical stuff didn't help. So we'll kind of gloss over some of this. So this is kind of showing the whole I am a thing, I have a thing, and now I am and have a thing, right? So we're showing kind of the inheritance composition. This could technically be the strategy pattern, the decorator pattern. This is all like the various gang of four patterns, kind of like just showing themselves right here. But getting into MVVM, right? So like we have, model view model, which is the .NET native way to approach applications. You have a binding engine, which responds to notify property changed events. And just because you're using the binding engine in the binding context does not mean that you're doing MVVM. And I'll tell you to go ahead and pick a framework, right? Like, don't roll your own. There's a lot of good frameworks out there. Find one, use one, understand it, and use it. I think so, we all know what MVVM is, right? We have our model view, we have our view model, the view has knowledge of the view model, there's data binding, and then the model projects stuff to the view, right? That's all basic stuff. We all know that, right? But that's all based on this I notify property changed interface. And again, interface segregation principle, like .NET provided you an interface that you could extend from, which is important, right? Anything that implements I notify property change can signal its property changed events, right? UI elements do it in Xamarin.Forms, like they implement I notify property change, which is how the binding context works. So the binding context being set, properties being set on the binding context is all I notify property change. When property changes, state changes, and when state changes, behavior changes, right? And that's an important thing. I notify collection changed. This is the unsung hero of the entire MVVM story. Not many people know about it, but this is what you generally want when you're trying to do observable collections. It deals with the add, remove, and clear methods of the collection itself. So it'll notify you when those things happen. It will not, observable collection will not notify individual state changes. And that's a very key thing. But Andres just gave a talk earlier about dynamic data and observable collections and how to get more lift there. So that's something I would urge you to check out. So all of that gets into like MVVM is basically just the state design pattern, right? Like it's fun when we can boil down these high level concepts into very simple things, right? So it's a behavioral pattern and it uses the state pattern objects that behave differently when the state changes, right? So there's going to be a number of states and transitions, and this is like a classic state design pattern, or a state diagram here, with your transitions and all that fun stuff, right? It's just a finite state machine. Your view model, right, is a finite state machine. It takes an input from the user, it takes an input from the model, it does what it needs to do, and it responds back out appropriately to the state changes on both ends, right? It responds back to the UI, it responds back to the model with whatever the model needs to do in order to update, or the service, or whatever the case may be, right? Like it does that communication, right? It projects its state change into your application, and internal changes that happen in your model layer can be then bubbled up through this MVVM layer as well, right? So this is a very important thing, like to understand that you really want your view models in MVVM to really just be state machines, right? When the user types in something, I want to go search. When they click a button, I want to respond, right? And then you can see how all the Gang of Four patterns start to come together, right? Like commanding pattern and all that stuff will also be involved in MVVM because we can use a command from our button to invoke something on the view model and create a transition and a behavior change. So how do I choose one, right? This is like the hardest part. There are three things that I usually talk about when I talk about choosing a framework. You want to look at the features, you want to look at the technologies that you're using, and you want to look at the targets that you're trying to support. So framework features, almost all frameworks have dependency inversion of some container or sorts that they use. They have navigation that will allow you support for like tab and master detail and potentially passing parameters, bindings. So older frameworks that predate Xamarin.Forms are going to have code level bindings which work in Xamarin.Forms, but you can use the XAML binding engine, which is just as good in most cases. And if you're doing a lot of XAML, you probably want to bind in XAML anyway. And then application lifecycle, right? So like restoring state from the background, managing dependency lifecycles. If these things are important to your application, you might want to see if the framework that you're picking supports these things out of the box or has a recipe for how to do it against the framework. Yeah, most support containers. Use one. I'm a fan of pure DI. I'm a fan of not hiding complexity, but on a large scale enterprise team, use a container. Don't be a hero. Navigation that you get from Xamarin.Forms is just stack-based navigation, right? There's push, there's pop, and the recommended way of doing things is passing stuff on the binding context. We don't really care about that binding context, right? What we need is we need to pass navigation parameters, right? We need to observe navigation events, and we need to manage view model lifecycle events, right? So we need to be able to do stuff like on navigated to, passing parameters that we can then unbox when we get to the new page and then set state. Setting the binding context will actually trigger a notify property change, which could be side effect code that you don't want. So lifecycle, how do we dispose of those resources? Making sure that we're implementing iDisposable and getting rid of any subscriptions, any event handlers that we may have used. Those things are important. And the framework should provide extension points for you to do this, right? Getting back to open close principle, there should be extension points in the framework that you choose. So use that as an evaluation criteria. And then whether or not it serializes application state. Does it have a recipe for that? Not all frameworks do. Some frameworks are working on it, but it's an important thing that we all deal with. Like, how do we get back from a lock? How do we get back from backgrounding? How do we get them back to the state that they were in? And then MVVM allows us to build once, right? Build once for web, build once for mobile, build once for desktop, right? I specifically have the Blazor logo there because now Blazor, like .NET, supports web in a way that is somewhat MVVM compatible. A lot of frameworks are starting to support Blazor in MVVM frameworks, which is a very interesting thing because now I can technically write an agnostic view model for mobile for my Xamarin application. And then later I can abstract these things, using good patterns and practices and provide a web application or desktop application that mirrors some of this functionality, right? So I can get some lift there. So getting into it, automation, right? Like what is automation? Automation is robots, right? But what do we want to automate? That's a thing, right? We want to automate work items, getting created, getting resolved. We want to automate the builds. We want to automate testing and releasing of our application. We want to automate these things because it will give our team lift, right? If it takes 5-10 minutes to build and release, then that's 5-10 minutes that it didn't take per pull request getting merged for some human to do, right? This is standard stuff. Everybody's probably using, Azure DevOps or Bitrise or whatever the case may be, whatever your build system of choice and you're shipping to App Center, right? These are things that we do. But the important part about the automation is let it evolve with your code, right? Find the bottlenecks, find where the build takes 10 minutes too long and reduce that, right? Because again, you want these things to be fast. We got to fail fast, which means we got to deliver and release fast, which means we got to get through our automation as quickly as possible. And I prefer to build once and deploy everywhere. And there's a pretty good article about that from Daniel Kauser that talks specifically about that, that I personally have referred people to talk about this concept. So yeah, continuous delivery, right? So we want to run code quality checks, cyclomatic complexity, code duplication, check for code standards, whether that be style cop or, Roslyn analyzers, whatever the case may be. But we want to automate the build, right? We just want every commit to build. I had a boss once say, it's just a repository. I don't care if what's in it builds. And I'm like, that's the wrong answer, buddy. We got to know what's in there is safe. We got to know what's in there is ready to release at a moment's notice, right? Because if we don't have that security, then, when somebody shows up to challenge the enterprise, we're not going to be ready. And that's a problem. We should automate tests, right? How do we get testing of each binary, UI, integration, acceptance, unit tests, all of these things. Deploying binaries, we got to release artifacts and we got to make sure that it ties back to our entire work stream product delivery pipeline. And then again, that continuous improvement bit, right? Like make them robots more efficient, because efficient robots means your process is getting better. So this is the big bag boogeyman that I find in the majority of Xamarin apps, is that we do not do any real level of automated testing. So again, UI testing is not my favorite. Sweeky does a really good one on page object pattern, but it has value, right? All level of testing has value. And that's what's important. When you've got 20 plus developers shipping 3 to 5 pull requests a week, that's 60 chances at minimum to introduce a regression. You're going to have manual testers testing a dev cycle build every single time something new gets pushed. That's a problem. Yeah, I can share that once we get off, I can make sure that that's part of the slide deck at the end, and I'll share the slide deck. So test the things, right? Use acceptance testing, unit testing. Everything depends on a unit testing framework. So like start there. I always say, hey, if you're doing UI testing, you're already depending on a unit test framework. So why? So yeah, okay. So given the current state, when the state mutates, I have an expectation of things, right? And blah, blah, blah. Slides are hard. So we want to test state, right? We want to test that state changes the way we expect. We want to test intersections of code. We want to, people can see me just in case. They can see me and they can hear me, good. So test dependencies as they're called, right? So here we are setting up a command. We want to verify that when the login command is called, that the navigation service gets hit, right, with the proper parameters. So we're gonna given the dependency, right, and the system under test. When the system under test does a thing, then we are going to verify that thing actually happened, right? And that's a very important thing. So testing view models, MVVM provides a great way to test. Use a unit testing framework. Again, these things actually enforce dependency inversion principle and inversion of control and single responsibility, right? So it makes your dependencies easy to mock. And then we can verify that the behavior is as expected. And that's important. So again, testing intersections, like here, we can actually test that when the thing is navigated from, that it does what it's supposed to do, right? So like now we're actually testing navigation in our unit tests, which is a very interesting concept, right? Like now we can test that we box and unbox the navigation correctly. And I know that a lot of people say that these tests are trivial. In isolation, they are, but just look out for brittle tests, repetitive tests, verbose tests. Verbose tests and complex tests generally mean that we need to reevaluate the pattern that we're using in that scenario. Testing allows you to refactor with confidence, right? Again, when you've got 30 to 90 pull requests a week coming in, you need that level of confidence to refactor, right? How many people have hit the thing and run the unit test and found out that they would have caused like a whole bunch of regressions, right? That's a really good feeling, right? It allows us to cover acceptance criteria and check for unintended side effects. But again, unit testing isn't the end all be all. So we need additional level of testing, right? Because this drives another important thing, which is maintainability, right? Older features are going to conflict with new features. New requirements are going to introduce contradictions to old requirements. But these things help us find regressions, right? Unit testing, integration testing, UI testing help us find these regressions. And when we run them in an automated fashion, it's very useful, right? Because then they give us information every single time we build, every single time that the MVVM application is written. And then the last bit is code coverage, right? Like, so I've worked on teams that had like 70% code coverage, but couldn't get a feature out the door. Code coverage is a metric. Like, look at it. Don't like hang your hat on it. It's not that big a deal. So like, you shouldn't abandon hope, right? Like, I talked about a lot of things, and I know I talked about, this is like a softer talk. This is a lot more abstract, but really what this whole thing is about is find the patterns, find the practices that work for your team. Use communication to get things done, right? You need a well-oiled machine to get through the enterprise, to make an enterprise application and an enterprise project successful, right? And that enterprise is going to be moving at light speed, right? So communication will help with team dynamics. Good practices will help developers understand how we solve problems and make sure that the way that we solve those problems is consistent. MVVM provides a consistent way to implement mobile screens, right? Because now we are not having to find a way to make this navigation work. We have a navigation service that's pretty straightforward, right? It comes out of the box and we can use it to pass navigation parameters. It gives and consistency is really that key to velocity. If we're not consistent in our approach, we actually struggle on velocity, because every single time that one developer has to do it slightly different, we create divergences in the way things are approached. Automating the processes allows us to get rid of some of the tedious, time-consuming stuff. And then test automation will make sure that we can continue to move at warp speed, right? Like, the test automation is really the biggest part of the thing. It allows you to make sure that as you're running at scale at 20, 30 developers worth of commits, that you're not introducing regressions with every single commit. So that's all I've got, and we'll open it up for questions.